Where my glasses are? Hello. We will get started here in just a moment.
Are we live?
I believe we are.
Hello, everyone. I'm just going to remove this test piece out of here. Turn it to 1080.
Yeah.
Awesome. Am I good to sit here, Hans, or you want me over here?
You can sit there, yeah.
Cool.
Solid. Okay, yeah, I just switched it to 1080 so that it's more friendly to that. So yeah, you can just.
Alrighty.
Or did it go back? It went back. Never mind.
Cool.
No potted plant?
We can get out the potted plant if you want to.
We don't have to.
Alrighty. Cool. Hi, everyone. Today we are going to be making a rubber stamp with the Optic. We're going to be making a slightly larger version of this dude right here. Maybe we switch to the smaller camera.
I can hold it up there.
Perfect. Yeah. So we're going to be making a small.
Yeah, no. It's still frozen.
Okay.
Yeah, give us just a moment. Technical difficulties.
Cool. Well, while we're getting that sorted out, guess I'll just hold it back up again. So it is a tiny multi-layer stamp with a layer of. It is sold as laser-safe rubber, and if I had to guess, I believe that it's a urethane rubber. It's the same material that most stamps are made out of. And then as the backing material, we just have a piece of 4mm pine, I believe. Yeah. And we are going to go through the whole process of making that today, and then we'll test it out at the end. And so here are the two materials that we are going to be using today. So we have the piece of wood here and the sheet of rubber right here. And I'm going to start by loading the rubber into the Optic. And for that, I am going to unlock the motors of the machine.
All right, we should be back. I don't know what caused that.
Are we live?
I think so.
Are the cameras working still?
Yeah, the cameras are all working.
Alrighty. Hi, everyone. Sorry about that. I think we are ready to get started. So we are making the stamp. We have our material loaded on the Optic. And is it possible to show the screen right here, Hans?
Yeah, we can switch to that.
Okay, great.
Robert, could you switch over to the LightBurn view?
The monitor's not working. You aware of that?
Yeah, I know.
Cool.
Just eliminating things that might have been causing issues.
Alrighty. Alrighty, cool. So what we have here is the Optic version of LightBurn, and then down here about I don't know, about half an inch away from either axis, we have the artwork. I'm going over to Cuts and Layers tab. And then here I'm going to cycle through the different layers and then talk a little bit about what each layer is doing. And so underneath the image are two vector layers. One is blue and one is red. The blue layer is for cutting out the rubber stamp. The red layer is for cutting out the wood. And the topmost layer is the image, and we actually have that inverted within our settings. And what this is going to do is it is going to engrave away all of the areas that are white as opposed to the areas that are black because it's a stamp, and so it needs to be mirrored from a regular engraving. And we are actually going to start with cutting the wood, I believe, because there is a little bit of post-processing on the rubber that we want to do while
post-processing is a fancy name for washing.
Exactly. Did you be able to load that in as you're actually to grab something?
Keeping it spicy.
Cool. Alrighty. Oh, sorry, I didn't mean to move it. So what I'm going to do now is turn off the output of the image, and then I'm going to turn on the output of the red layer.
We should do a quick overview of how we have 3 layers, one which is our engraving for the stamp, one which is a cutout for the stamp itself, and then one which is a cutout for the backing block. So you can see here, that's represented in those 3 layers are represented in this piece here, where we have, going from back to front, the wood backing block, then we have the actual outline of the stamp material, and then we have the artwork of the stamp. And so that's divided into 3 layers. It's really super simple to do that from, say, a program like Illustrator, to just bring in 3 separate layers and have them all ready to go. Just, I guess, designed for laser cutting, you might call it. Yeah.
I'm actually going to reposition the wood slightly.
You want to at 1-1?
Yeah, that'd be great.
At 1-1.
We good? Alrighty. And so I am going to start out by cutting out the wooden outline. And so I'm looking at it and see that it's red. It's my red layer, 3rd one down.
Right, I'll zoom in a little bit.
I am showing all 3 layers, but I only have the output turned on to the red line. Before I start anything, I'm going to go over to my monitor and make sure that it is going to do what we want it to.
Yeah, and that little preview that you pulled up, you get that by hitting the little, it's basically like a little monitor icon in LightBurn, and that's the preview. I'm not sure if that's an entirely best representation of a preview, but that's what it does.
Cool, I think that we are ready to go. I'm gonna move. And I've already focused the laser to the height that we want, which is focused to the very top of the orange, which is a little bit thinner than the wood. That's okay. We want it to be focused down a little bit into the depth of the material because we're going to be cutting out the wood. So I'm going to go ahead and hit start on the machine.
The laser beam is essentially like an hourglass, and so at the center of the hourglass is the sharpest point, which is the best for fine detail engraving. And then beyond that, you have a wider beam going up and going down, and you want a little bit of a wider beam for cutting, and you also want to put that hourglass right in the center of your material when you're cutting. That just gets the best cut performance.
Robert, could we switch cameras to that one?
Give me 100.
What's that?
100. so this is a bit that I'm not entirely sure if we talked about before, which is the leveling gauge. Have we talked about that already?
Go for it.
Well, always worth talking about again. This one has 3 steps, one which is for engraving, so fine detail stuff.
Hold it lower, I think, a little bit.
One which is for engraving, one which is for cutting, and one which is in between. So you want to be a little bit lower down for cutting because you want to put that hourglass of the beam in the center of your material in terms of width. That's pretty much it. A very simple but effective tool.
Be here.
That's probably audio sounds.
What's that?
That's probably audio sounds of the fans.
All right, we just got in a question. What kind of laser are we using? The laser that we are using is a multi-diode.
Solid state.
Thank you. Sorry, I was loading.
Finding the word.
Yeah, multi-diode solid state laser that uses 2 450 nanometer wavelength.
Blue light. Yeah.
Blue light diode lasers, and then are combined into a single beam. So this is the first piece that we cut out, and there is a little bit of post-processing on that, but I'm going to leave that for once we have the orange rubber engraving, because that's the most time-consuming part of this project, because since we're removing so much material, it is a little bit more of an aggressive engraving that takes a little bit longer than as if we were doing a cosmetic engraving. So we're basically machining away. Robert, is this the active camera? Yeah. Fantastic. We're basically machining away all of the sections that we don't want to pick up ink. And so we have to go slower and deeper than we might if we were just engraving on something like wood, or like if we were engraving on like a cutting board or something like that.
And yeah, to elaborate on the type of laser thing a little bit more, if you've heard of like say CO2 lasers before, this is very different than that. This is, imagine it like a really, really bright LED. That's effectively what it is. It's a little bit more complicated than that in the technical aspects, you know, when you really get down to it in the physics. But it's essentially just a really bright LED, which allows it to be so compact relative to, say, a CO2 laser system. It doesn't require a water chiller, doesn't require high voltage power supply, all that sort of stuff. And it can just be really super compact. And I think previously we've had comments about, I guess, skepticism about powering it off of a laptop charger, and being able to fit motors, fans, and the laser within such a small amount of power. And that's really where the solid state laser comes in. Yeah, go ahead.
All right. And so in LightBurn, I am turning off the output of the thing that we just cut, which was the outline of the wood, and I am turning on the output of the image that's going to be rastered. And then I'm going to check on the preview, and the preview is inverted, of course. And just scrolling through, it looks as though it is doing exactly what we want it to. So I'm going to hit OK on that, and then we are going to get started. If it looks.
And so
looks okay.
We're going to answer some questions from the chat. Benjamin Kirkland asks, other than maximizing the material, are there any issues if the alignment of the material is off? And the simple answer is no, not really. There aren't really any downsides to having the material misaligned, per se. Really, all the alignment that you need to do is done for you in the program, LightBurn, or really any program that you're using, because it can work with programs other than LightBurn. But all the alignment is done in the software and on the machine. Mm-hmm. It does it for you. It's very precise. So if you were to engrave something and then cut that out, it'll line up every time, and you don't have to worry about that, just as long as you don't bump the material. There are ways to like recover bumped material, I guess, but really, yeah, that's pretty much it.
Just to add a little bit to that, the digital grid that we see here in LightBurn, Robert, are we on LightBurn? Awesome. So this grid that you see right here, this matches the engraved grid on the cutting mat on the Optic. So if you put your artwork at a certain location digitally, that allows you to place your physical material in the same location, ensuring that your design or cut will be exactly where you want it to be. So if I was engraving the back of my phone, for instance, I would set my phone at a certain intersection of lines on the cutting mat, and then I would be able to place my artwork in reference to that intersection digitally, and then it would line up exactly where I wanted it to.
That's one of those things that's just so intuitive about the machine that you kind of forget that isn't really present in a lot of other machines. The grid in the software is the grid on the cutting mat. And I see there's also another question about the cutting mat regarding does it cut through to the bottom? And the answer is yes, but not in the way that you might think. So the cutting mat is very durable. You'll never be able to cut through it just simply because it's acrylic composite material, ACM, and it's very resilient to the laser. Not because the laser is weak, but just because the ACM is very strong. And so the most that you'll get on that bottom grid, I think they called it a tray. Yeah, so it's the cutting mat. The most that you'll get is like kind of a ghost of whatever you've cut out. And even that, if there's like some residue left behind, cleans off extremely easily with just water. And if there's anything that sticks around longer than that, a magic eraser will remove pretty much any dirt from the machine really super effectively. So.
Yeah, and that was from, we don't have a name on. Oh, the previous question, the one about the laser, that was from Evelyn Hay Primus.
And then Benjamin Kirkland asked about the material maximization, and then Creative Expressions and Gifts asked about the cutting mat.
Yeah, and so at the end of our project, we may actually show what the cutting mat looks like and potentially clean it. We'll see if we have time. I'm going to move on to cleaning out this wooden piece while the machine is engraving the rubber. And I'm going to go ahead and move this camera.
I realized I might have said acrylic composite material when I was talking about the cutting mat. It's aluminum composite material. Sorry about that. Amber Bowl asks, do you recommend ventilation? Simple answer, no, because the machine does all the ventilation itself. With something like a lot of the commonly available diode laser systems from China, they don't have any ventilation whatsoever, and they kind of don't acknowledge that ventilation is a thing, which is really important if you're using one of those systems. And that's kind of what makes the Optic special, is that it integrates that ventilation, that filtration into the system.
If I could just add a little bit more to that. So the Optic doesn't require you to have like a tube running out to a window or an external fume scrubber, because it has an integrated filter right here. It is currently the only laser cutter with 100% integrated filtration. So if you see, we can just have it on the desk, and there's no fumes coming out of it. If the Optic didn't have an integrated filter, the whole room would be full of fumes, and it would not be great. And so on the topic of ventilation, we do suggest always, working in a room with, some sort of airflow, whether it be your AC system or some other system, because the material that we are laser cutting will still be off-gassing after the laser cutting process is done, and it will be off-gassing during I guess, assembly when you are like done with it, if you're assembling it or something. And so we do recommend working in a ventilated environment, even though specific filtration for the laser cutting process is integrated.
And of course, make sure that you have things like carbon monoxide and smoke alarms, which you should definitely have anyways, regardless of whether you're using a laser cutter. But those are definitely something that is important when using something that is kind of burning material or cutting.
And so what I'm going to be doing with this piece of wood right here that just came off the laser is I am going to use this fine sanding sponge, about 400, and I am just going to sort of run it around the edges to remove any loose char from the laser cutting process. And then I'm going to sand the top of it and the bottom of it so that it's nice and smooth, because this is a finished part and you're going to be touching it and handling it, and I'm just going to make it a little bit nicer.
So it doesn't put soot on your hands. Sir Catlord asks about how thick can the laser cut. The simple or short answer is it depends on the material. And the slightly more complicated answer, giving you just a rundown of different materials that it can work with. It can cut up to 10 millimeter plywood. What would you say, quarter inch? How thick acrylic would you say?
So it depends on the color. If you're working with black acrylic, you can cut up to about 6 to 8 millimeters thick. And other opaque colors of acrylic, you can cut up to about 1/8 of an inch, about 3 millimeters.
Cut pretty much any cardboard, paper, cloth, vegetable tan leather. I don't know.
Toolbox foam is a fun one.
Yeah.
You can cut 1-inch toolbox foam. You know that you have in Pelican cases. That's a project that we've done that we really enjoy. And so with that, actually, you take the optic off of the cutting mat and you place it directly on the foam because it is thicker than what can fit underneath the gantry. The optic has a gantry height of about 11 millimeters, and so if you want to use it with the cutting mat on, that is going to be a factor that you need to take into account, is the height of the gantry.
And then Myron Cutout from Facebook, sorry if I butchered that, asks, is the filter cleanable or disposable? I don't know about disposable. I think that you can just throw it away. I don't think you can recycle it. You might be able to recycle the casing. And as for cleanable, no. Basically everything that goes into it is like pretty nasty. However, there is a pre-filter which is cleanable. That you can just simply wash under the sink, and that catches just some of the like larger stuff in the filtration system. So
our filtration system in the Optic works very similar to like a Brita water filter, where the case itself is meant to be capped with the product, but the actual filter cartridge itself is disposable, and you dispose of it after it is full, saturated, and then you replace it with a new one. And that is this piece right here.
We have a question from Dreco1971 asking, activated charcoal filter replaceable? And yes, the filter is for sure replaceable.
I could talk about the activated charcoal.
Yeah. Are we in a position to talk about the filter technology right now? I don't know if that's locked down really.
The way that our filter works is it has multiple stages. The initial stage is a mechanical filtration step, and so that is filtering out any sort of physical particulate within the fumes. And then there are other stages that do contain activated charcoal that remove any sort of the gaseous irritants that could be in the fumes.
Things like carbon monoxide.
Yeah.
And I wanted to jump back and grab a comment from Sir Catlord again, saying that stamps are reverse image engraving, and yeah, I don't know whether we actually explained that properly. What we're doing is we're removing all the material but the image, so that it's in relief, it's negative. Yeah, engraving, yeah.
And so I am done.
Just going back and catching that.
sanding the little piece of wood, and I'm just wiping it off with a tiny alcohol wipe to remove any other loose ash or soot that would be on it.
Let me go grab a filter so we can show them what it looks like.
And so, and what I'm also doing is using the alcohol wipe because that is removing any sort of residual sawdust that would be on the surface from when I sanded it a little bit. So it looks like the Optic is done. And I am going to move the gantry out of the way. While I do that, I'm going to answer a question. So Eli Rosen asked, how durable is the arm holding the laser? The design seems like it could be delicate, especially if accidentally pressed on. And so
The answer is surprisingly durable.
Yeah.
That's the straightforward answer.
I'm not going to fold it up right now because I need it to remember its position for when we put the rubber back in. But after we are done, we'll be able to fold it up and get a little bit more detailed about how the arm works. So, Robert, could we switch to this camera right here? Alrighty. Cool. So this is what our engraving looks like straight out of the Optic. This material, when it engraves, it sort of turns into dust, and then that sort of clings to the surface. And so since we're done engraving it, what I'm actually going to go do is wash it with some soap and water, sink right over there. We're going to put it back in, and then we're going to cut it out because the material cuts better if you remove a lot of the particulate from the engraving process. So I'm going to go do that right now, and Hans, I think, is going to answer some questions.
Yeah. So this is a filter that the Optic uses. They are replaceable. You can just move this out of the way. They're interchangeable. You can see this one looks a little bit dirty. This one's nice and fresh. From my experience, they do last quite a good while, and it's pretty impressive how much they can do in such a small space. There's a lot of really pretty advanced technology that goes into the filtration system, including the filtration material and the stages and all that sort of stuff. Yeah, I think Caleb pretty much wrapped up the comments about the arm, but it is very durable. We haven't talked about it in this stream yet, but I think we talked about it in a previous stream. Because of how they're kind of a modular system, where there's a lower body and an upper body that are kind of independent from each other, it's really super durable, and there aren't any fragile bits really between the two. It's just a connection between the upper and the lower, and it's super reliable, and I can definitely understand how this may look like a fragile system, but the reality is that it's a very, very engineered combination of elements. Jumping on to some more comments from Maysun025. I like that everything is integrated. It makes it easy to use. And yeah, for sure. Even having worked on this machine for a long time, I am still regularly impressed on just simply how easy it is to use and how quickly you can just set it up and just start using it. We have access to another laser system, a CO2 laser system, more like a more traditional, big, huge, whole room sort of thing. And it's just night and day difference between how long it takes to set everything up, all the different steps, and this, you just plug it in and it's just ready to go. And combined with how you can just put it away, it just still impresses me continually.
Yeah. So I cleaned out the all of the sort of soot from the engraving process out of the workpiece, and I'm going to be setting it back in the machine and lining it up again at the same grid location on the cutting mat. And then we are going to be able to run the code that will, or send the cut basically to the Optic that will cut out the rubber stamp.
Yeah, and so Jay-Z asks, or says, "Hi, great demo. My question is for someone with no prior experience with laser cutting or the software. What is a typical amount of learning hours to become proficient with the machine?" I would say that you can get up and running and start cutting your designs within, I don't know, 30 minutes to an hour of
Unboxing it.
Yeah, just setting it up, unboxing it, and getting familiar with the software. However, LightBurn is a really seriously powerful piece of software, and if you put in, you know, another hour here, another hour there, it can do some really impressive stuff. Things like image engraving are a little bit more difficult, just simply because there's a lot more variance in how you set that up to get good results. But if you work with it, it'll give you really good results. And it can do really super impressive things with combining different layers, doing different cut settings, different types of engraving. It really is a super powerful, not just a tool in itself, but a toolbox of things. It's its own vector editor. You can create artwork directly in LightBurn. So it really, you know, 30, 45 minutes to get running with your designs, and from there it's just kind of like the world is your oyster. You give it a little bit more time and it'll give you a whole lot more.
So it's similar to 3D printing in the way that you can pull designs off of the internet or any sort of repository that you might have of images or vectors, and immediately start laser cutting them out of paper, plastic, wood, fabric, whatever you want. You don't need to be a designer or an artist in order to make awesome things with the Optic. And so really, the machine can make as intricate and complex of projects as you want it to. If you are a beginner, you know, you could start out with engraving on things that you already have around. Like if you want to engrave on your wallet, it's really easy just to place it in the machine and then bring some text in LightBurn, and then you can immediately start customizing things you have. You want to engrave a design or a logo or something on like an iPad, you can immediately start with that. And then there's also lots of repositories online of laser cuttable designs. There's a lot on Thingiverse. There's a lot on GrabCAD of people just publishing designs that you can download and get started with. And then as you, if you're coming sort of from a background in design or engineering or art, and you want to or have the ability to design your own files in Fusion 360 or Illustrator or really whatever tool you want, then you can bring those designs into LightBurn, and then you can immediately start cutting out your own designs out of whatever material that you want.
Yeah, before we get started with this final cut here, I wanted to mention the giveaway that we're doing just once more, read the specifics of it. For our giveaway, we will mail 1 stamp each to 3 lucky winners, US and Canada only right now. And so to enter or earn entries in, how to earn entries in the giveaway, you can invite a friend to the Facebook event and tag them in the Facebook post comments, tag a friend in the comments on Instagram, on the Instagram giveaway post, and attend the live event on Facebook or YouTube. I might have messed up the wording there, so read the description for the exact details. Yeah, and then we have another question from Vignesh Subramanian. So again, sorry if I messed that up. Asking.
Mike, start this cut, by the way.
Oh yeah, go ahead.
Okay, great.
Asking, how do you focus the laser on the material? And we mentioned this earlier, but again, can't hurt to talk about it again. We use this focusing gauge. You simply put it underneath the laser module, and you release a lever, move it so that it touches, and then tighten the lever. It's a very straightforward process, really super simple. And this one has 3 steps for cutting, engraving, and kind of an in-between setting. if you want to see more detail on that, I talked about it a little bit more early in the video. And then Pixel Designs asks, can you pair two lasers to cover a larger area if you're working on a larger piece of material? And that is a fantastic question because it's even better than that. You don't have to have two lasers to work on a larger piece of material.
It'd be cool to see, though, definitely.
Yeah, it'd be cool to see two working together, but you don't actually need to. This machine can do a combined sort of like tiled workflow where you can work on material as big as you can get a hold of. So we'll post a link in the chat to a video where we're demoing that exact feature, where we cut out a sign that's, what do we say?
It's like, yeah, 2.5 feet by about 4 feet.
Yeah, it's pretty big.
And so,
way bigger than the machine itself.
Yeah. The way that works is you would remove the cutting mat, and then you place the optic directly onto the material. You would cut or engrave your first tile. You would move the optic, and then you would tell LightBurn where the optic is.
It has a self-alignment feature, so you don't have to worry about doing tedious alignment. It will actually adjust everything relative and simply correct it for you. It's a really super powerful feature. Hopefully here soon we'll have a video demoing exactly how to do that with the optic, because I think that people were really excited about that particular feature. Yeah.
Cool. And then if you move the phone back over here.
Yeah.
And we don't have that tiny camera, right? No. Alrighty.
And then Myron Sidonch asks, you earlier confirmed that bas-relief cutting is possible. Can you please share more technical detail on how that would work? So essentially, the principle is that you take your positive image, you outline it, and then you invert it. Mm-hmm. Is that a clear description
so
of what
similar to what we are doing with the stamp, the black parts of the design is going to be all of the way engraved directly down into the surface, and a white section of your image is going to be left alone. And so that is how LightBurn and the Optic calculate how deep to engrave the artwork. And so if you have a variable color image, like just a picture that you took, then you can bring that into LightBurn, and then it'll automatically turn it into grayscale, and then it will tell the Optic how deep to engrave certain sections of the image, effectively creating a 3D representation of your image on your 2D material. And so the Optic just finished cutting out the stamp. As you can see right here. And I am, again, going to wash it because this material creates soot that sticks to the rubber.
Very dirty. Cleans up nice, though. Matthew Marcini asks, what parts are consumable and what is their longevity? I can give you a good answer to the first one and a pretty good answer to the second one. So the parts that are consumable are pretty much just the filter and also the pre-filter. I don't know if we have a pre-filter readily available, but this is the filter, the main filtration component that is consumable. The pre-filter is washable, and this is just disposable. You use it, it gets full, you throw it away. And then other than that, pretty much everything will last the lifetime of the machine, which is quite a long time. If you heat up the laser too much, that could reduce its life, and you could replace it, but that will never happen during normal use. We've used this particular machine quite heavily, gotten it really, really super hot, way hotter than you would ever get it during normal use, and it still performs just fine. So theoretically, maybe the laser module is a replaceable part, and we'll have replacements available for that, I believe. But it wouldn't ever fail or need to be replaced during normal use. And then PC Italian asks, what is the estimated MTBF, which is mean time between failures? We're working on that, so we actually have all the components here, just like really just right out of frame here, for 10 machines, which we're going to be doing accelerated lifetime testing, which will tell us essentially that mean time between failure. Because of the nature of the machine, we're not actually going to do a mean time between failure per se. That's, I think, more on the component level than the whole machine. But we'll figure out exactly what will fail and how long everything will last. And you say make corrections or improvements based on that. So far, we've been using this one particular machine for, I don't know, six months, I'd say, so far. And it's doing great. The only things that have had issues are things that are just kind of like, because there's only one of these, it's been hand built. And by the time that these are actually going out to you guys, all those issues will be completely non-existent. Things like, you know, hand wiring that isn't necessarily perfect. And that will be perfect in the actual final machine. Yeah, that's a great question. Creative Expressions and Gifts asks, Rendyr, is LightBurn a software you have developed, or is it a standard software? So it's actually kind of both. It's a software that we did not write the initial piece of software. It's something that you can get for laser cutters, just any laser cutter pretty much, and you can use it with any laser cutter. It's not necessarily specific to the Optic. However, we have a package specifically for the Optic. If you're familiar with Prusa and their version of Slicer, or Slick 3R, or however you want to pronounce it, it's a custom version of that piece of software for their machines. And that's essentially what we have for LightBurn. We have a customized version that has all of the machine parameters, all of the cut settings. We have a whole material library, and basically just everything that you need to use the Optic most efficiently is just in a software package, or a information file package, I guess, that goes with the machine, and you just load up into LightBurn. So the answer is both. It's both a custom and a standard software.
I'm going to go wash this again. I didn't get all of the soot out of it, but I just wanted to add a little bit to the sort of a couple of different questions. One, the mean time before failure, and
yeah, we should mention that this is not the only version of the machine.
Yeah.
We have made many, many, many prototypes. This is just the most refined, you know, latest version.
Yeah, and so to also talk about the durability of the arm, since we are done cutting, I think I'm going to actually be able to unplug and lift up the machine. So every aspect of the kinematic system is either steel or aluminum. There's.
I'll glue the stamp while you do that.
Would you actually be able to wash it a little bit more, Hans?
Yeah, yeah.
Maybe a little bit of alcohol. I think we reached the point where the soap and water isn't getting the last bit. And so every aspect of the kinematic system is either machined aluminum or hardened precision ground steel. And so both chassis are aluminum. Each rail is, firmly mounted in place, perpendicular to one another. And as you see the hinge, the lower plate is machined from 6061 aluminum. There is a custom bronze bushing that the central hinge pin lifts in and out of and rotates. And then there are large, robust aluminum pegs which sit in holes precision machined, both in their diameter and their length from one another on the plate, ensuring a very tight and robust connection mechanically between the upper body and the lower body. There are also pogo pins and contacts between the two hinge plates, which transfer power and data between the lower body and the upper body. In terms of the rest of the kinematic system within the arm, the laser head is moved from left to right using a stepper motor with, I believe it's 1/124th microstepping. It rides on a precision ground
Very
linear
precise.
rail, and it uses Kevlar reinforced GT2 belt in order to make sure that the laser goes to the exact same point every time with your artwork, and that it can return to that same position every time you're doing a project. And so I think that Hans is happy with the results of the stamp, and we're going to be gluing it on the backing material now. And for that, we are just using a couple of drops of super glue, and then we are gluing the rubber stamp to the stamp base. Are there any more questions I can answer right now?
And so is this actually rubber? I know that it's like a laser-safe material.
I think it's a urethane rubber, yeah. I'm not sure if the word rubber has a specific, I guess material makeup that makes it rubber, or if it's just sort of a generalized term for flexible materials, but that I think is urethane. All right.
I'm not using enough glue.
Seems like people want to see how the optic folds up all the way, so we're going to do that. The upper body lifts up and disengages from the lower body, and then make sure you don't catch your sweatshirt in it, and then it clicks in and sits flush above the lower body. The cutting mat magnetically attaches around it, and then it's a complete sort of package that you can move around and set up and put away and do whatever you want with. What other questions do we have? Is there, PC Italian asks, is there a duty cycle for the unit, i.e. how long can you cut, burn before having to let it rest? It's a great question. If you are using the optic within its recommended temperatures, that being, room temperature, then there is no duty cycle because it has an integrated active cooling system that keeps the laser under a temperature which could cause it harm. And then there's also a temperature monitoring system that if for whatever reason the temperature goes above a safe limit, the optic will turn off the laser and then move the upper gantry and the laser out of the way. And then it will wait until it is back to within a usable temperature range. So under normal operating temperatures and conditions, there basically is no duty cycle of the machine. Well, I guess there's an infinite duty cycle because you can just 100%. Use the machine continually.
100% duty cycle.
Thanks. So here are the two stamps. Here's the one that we made earlier as a test. Here is the one that we made here. It's a little larger because I wasn't quite sure how large our ink pad was, so made it tiny. It's a little bit bigger, so we made a larger one to make it a little bit easier to see. And so this is what it looks like, and I think we're going to give it a test. So this ink pad is just a regular sort of stamped ink pad that you can get from Michael's or someplace like that. This one right here is an ombre ink pad, so it's a gradient. Interesting to see how that will look. And I am inking him up. I can't get, is that just one? Yeah, this. Alrighty, and that is the first result.
I'll take it closer.
And think I'm gonna try it again, Hans, real quick.
Well, since we've wrapped up with the laser cutter for now, I can show you one of its very cool features. You can just pick it up like that, just put it on a shelf, out of the way. That's it. Just a whole laser cutter just sitting there on your shelf. I'm not sure if my head's in frame.
Alrighty, let's see if I can get one perfect one.
Honestly, this is more about the art of stamping than the stamp itself.
Cool.
Yeah.
Those are some tries. You want to show those? And here's the stamp. One last question, Eli Rosen. Is the pin that the arm swivels on replaceable? If you manage to break the central pin, which is I believe it's, I'm not sure the exact alloy, but it is stainless steel and 6.5 millimeters in diameter. So under normal operating conditions, you should never need to replace the pin at the center of the hinge plate. But if you, for some reason manage to need a new one, then we would definitely be able to supply a replacement for it. And I think that is all we have time for today. Thank you guys so much for joining and seeing us demo a little project with the Optic, and we can't wait to see you guys next week. We are going to be demoing soft goods, I believe.
Soft goods?
Yeah, I think we're going to be making something out of felt or leather.
Textiles, that sort of stuff.
Stay tuned for that, and we will see you all next week.
Thank you so much.
Have a great weekend.